BCX. When you married to a woman, or when you married to a girl, or when you married to a guy, always remember it comes with the family. Don't say, love, I only love you, but I don't like your mom and dad. Does not work like that. Are we clear? Same ideology. If we have a BCY going up, we have to have a BCX going towards the where? Towards the left-hand side. So when this is the case, we know that this is our what? Eugene, seriously? This is our F what? Our FBC. Now, next, I want you all to focus on BC. Right? We are going to apply Newton's third law again. Action equal reaction. Same in magnitude, different in what? Action. So now you can see that FBC is going in what? And so. This has nothing to do with experience. This has to do with knowing Newton's which law? Third law. Third? Yeah. No acceleration yet. Now, have you tried fixing a problem and then the shit went worse? I have. Right? You try to fix a problem, then like, oh, crap. It's normal. If you get it right the first time, you learn nothing. If you get it right the 100 times, you find 99 ways why it's wrong. Life. Now, what is the problem now? Anyone? So we prevent the dot from going what? Upwards. But preventing the dot from going upwards, we have what? BC what? BCX. So now the dot want to move towards the what? Left. Newton's third law. Now we know we have to counter this, and this is known as our BC what? AB what? X. Yes or no? Action equal to reaction. We are going to have a reaction at point member AB. And then finally, AB is in what? Compression. So is this correct? Yep. Is this correct? Yep. Are you comfortable? You're comfortable now? Okay. Yes. Neutral axis means it can be on, it also known as the axial axis. Okay. It's another term for it. Okay. So it's on the axial direction. Okay. Does this make sense to all of you? Yes or no? Yeah. So like what we wrote earlier, right? So we know K is equal to AE over what? L. Yes or no? Right? So we also are aware that this can be represented by this. You see it now? Right? So we know that this spring is going to what? Tension, and this spring is going to what? Pressure. Okay, so this is our X and what? Y. Okay, are we clear? Okay, so now you can visualize what mechanical system like in a structure relative to a real world, and I hope this will embrace you with the confidence to determine whether a structure go in tension or a structure go in what? Compression. Okay, so you have to what? The most important thing is you have to apply which law? Newton's third law. Clear? Okay, no doubts. Okay, if mechanical engineers have doubt with this, it's as good as an electrical engineer have doubt V equal to IR. Yeah, I have doubt with that. Can't see it at all. This you can see. Are we clear? Right. Questions, anyone? We okay? Right. So let's now go to a undamped. Free vibration. Okay. So what we have now is we have a spring, and this is our K. And then with our spring, we attach a load. And because we attach a load, what we have is a mass, and then we have K. Okay. So I'm going to write this down, the weight of the load is equal to 89 Newton. And when the spring, okay, when there's a load, this is our delta Y. Okay, so extension of spring due to the load is equal, so this is our delta Y. This is equal to 0.1 meter. And we are going to declare whatever is positive is coming down over here. Okay. So this dot over here, this line over here, is known as our equilibrium position. Okay, the spring extend due to the load. Okay, so what we want to do now is if we are going to determine relationship between time and displacement. Okay. So if we look at the general characteristic equation, right? Or we look at the full form. Oh, sorry. Let me know if you finish copying, okay? Or anyone have any questions so far? Okay. What do you call exploding monkey? My wife don't find this funny, but what do you call an exploding monkey? Baboon. Gee, you guys are sad bastards today, man. Yeah, I was told this joke on Lion Safari when the driver started. I could not stop laughing until the end of the trip. And my wife like, why are you laughing? And up to today, sorry, dark humor. Right. Coming back to here, so we know the characteristic equation. I got some really evil ones, okay? When it get boring, we go there. So the characteristic equation we know is m d squared y over dt squared plus by c dy by dt and plus by ky, the whole thing is equal to what? 0, right? And we know, right? We know that alpha is equal to c over 2m, right? And then we are aware that beta is equal to c squared minus 4mk over 2m. We are aware of this. But in the system that we have, but for undamped, now be careful, okay? Undamped and underdamped are two different things. Are we clear? Okay. Don't be like me, okay? See, but look, nothing. Okay. So undamped and underdamped are not the same thing. Okay, so for undamped system, we know that C is equal to what? 0. And when a system is undamped, it will comply to Newton's first law. Okay? It will comply to Newton's first law because there's nothing to absorb the energy, and the structure will go like this. So this is time, and this is our distance y, right? So for an undamped system, okay, not undamped. So let me write underdamped for underdamped. Okay, so for underdamped system, we have spring, we have damper, and we have a what? Mass. The solution looks like this. For under what? Damp. If you look at this equation, does this equation fit this signature? Yes, why? No, why? Anyone? Yes. Yeah, so it does not decay. Remember, this is our what? Decay what? Term. Okay. When I was young, my sisters, when I was young, I asked my sister math. She's the top 5% in class. I'm the bottom 5 because I watch TV 48 hours a day. I have 2, one left eye watch one right I watch the other one. And I asked her a math question, and she told me, Eugene, math is a language. This was when I was grade 4. Any idea what I told her? You crazy beep, 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 beep. Okay. But she's right. Okay. It's the decaying function that is there, and this is not right. So the next one is where we have what? Can you see the difference? It can be called undamped or what? Undamped, either one. Okay. So undamped, you have a what? Spring and what? Right? So if you look at the alpha and beta, what terms go missing? Right? So I write down again. So if alpha is equal to C over 2m, right? And beta is equal to square root C squared minus 4mk divided by 2m, right? So when in an undamped system, this is equal to what? 0. When it's an undamped system, this will also be equal to what? 0. Okay, so from when this is the case, what we have is y power t. So let's put every term in. E minus alpha t, C1 cos omega dt, plus by C2 sine omega dt, right? This term will go to become what? 0. E to the power of 0 is equal to 1. So finally, we have what we have over here is C1 cos omega nt plus by C2 sine omega nt. So what is omega n? Omega n is equal to what? Is equal to 4mk divided by 2m. Okay. So when we were to take out, okay, remove the square root, so we have 2m squared, or wait, what am I doing? If we were to remove the square root is still there. Okay, so if we were to all of a sudden I'm having a brain fart. So now if we were to include the square to the bottom term,